given a polynomial x cubed plus bx squared plus cx minus 14 with real b and c and a root, which is 1 plus I, you would like to solve f of x is equal to 0. So you want to find the other roots. I mean, we want to find the other root. So what do? Well, you can guess. Try to guess here and there. You have 4 choices. You're stuck on the exam. Just choose one. But that's not very wise. So the thing is, with almost every question you'll face, you'll be given a set of tools. And to be able to reach the solution, you need to be able to utilize those tools to carve your way to the solution, so to say. And so if you're not using them, then you know that something is wrong. What are the givens? What are the tools here? Well, we know that b and c are real coefficients and z is a root. Z is equal to 1 plus I is a root. So z is equal to 1 plus I is a root. And this is real. This is real. And this is also real, because there's a coefficient of 1, which we usually don't write. And it looks like, if we take a good look at this polynomial, we'll find that this is a polynomial which has all of its coefficients real. So all of the coefficients are real. This is the first observation. And the second observation is z is equal to 1 plus I is a root. Then, now is a good time to summon this theorem, or this result, so to say, which says that if f of x is a polynomial with real coefficients, and this z is a root, then z star is also a root. So if z equals to 1 plus I makes this function f equal to 0, and this function f has real coefficients, then this is a root. Then z star, which will be equal to 1 minus I, just take the conjugate, is also a root. Okay, so that's good. So that's some progress, right? And now the following observation must be done. And that is, this is a degree 3 polynomial. So it has how many roots? And by the fundamental theorem of algebra, we can write f of x as a product of its roots. So let's say the first root, let's say the second root, then let's say the third root. Okay? Well, this is good because we know what the first root is, we know what the second root is, so we might as well write them down, right? I would really rather keep them in brackets. I don't want to expand the brackets. You'll see why in a moment. So 1 minus I, and then x minus R3. And then there's a very tiny piece of information that we still have not utilized, and that is the constant value. So I don't know if you've noticed this. I mean, it's very weird. Like you have x cubed and bx and cx, but minus 14. Why minus 14? Yeah. Well, it has a certain implication, and that is if we know that this is also the same function, then this constant is the constant which would arise from this polynomial. And try to think about how we can get a constant out of this. Even better, think about how we can not get a constant from this. And the way to do so, the way to not get a constant, is to multiply by x. If you multiply by x, you don't get a constant, or here or there. So you want to have a product which does not have any of the x's. And simply this is 1 plus I times 1 minus I times the third root. So this implies that minus 1 plus I times minus 1 minus I, so two minuses cancel out, and then there's a third minus, so times minus R3 is equal to minus 14. So minus 14 must therefore be equal to minus of the three roots, which are 1 plus I, 1 minus I, and R3. Again, the minus is here because we have three minus signs, two cancel out, and the third stays, making this clear. And if this is true, well, then I can just divide by this minus sign, I can just remove it from both sides. And when I do so, I have this. The third root and an equation in one variable, so I can actually solve that. 14 in that case would be equal to the product of these two, which is 1 squared plus 1 squared minus negative 1 squared, because this is a difference of two squares. So it's 2 times R3. And from here we get that R is equal to 7. So these are the three roots. This is the third root, this is the first one, and this is the second one. So you need to also observe that the product of the roots is the constant value in any polynomial, just by the fundamental theorem of algebra. Fundamental theorem of arithmetic is another thing that we will not be discussing in this course. This is it.